Back in 2017, astronomers spotted something truly strange. A long, cigar-shaped object was zipping through our solar system on a path that made no sense. It wasn't looping around the sun like a comet or asteroid. It was on a one-way journey. In, then out. They named it Oumuamua, a Hawaiian word meaning a messenger from afar who arrives first. But its shape wasn't the weirdest part. Unlike comets, it had no icy trail, no heat signature, and no visible propulsion, yet as it got closer to the sun, it suddenly sped up. No engines, no vapor trail, just motion that defied physics. For years, scientists were left scratching their heads. But in 2025, new technology gave us a fresh look. And what researchers uncovered is raising more than just eyebrows. It's raising alarm bells. The twist? The acceleration wasn't random. New analysis by Michio Kaku's team, using cutting-edge quantum-enhanced optics, showed the object's speed increased in a way that perfectly countered its tumbling rotation. Every 7.3 hours as it spun, its acceleration adjusted exactly, keeping it on course. Natural objects don't do that. Comets don't self-steer. Asteroids don't fine-tune their flight. Then came another surprise. Tiny shifts in acceleration perfectly matched the object's orientation toward the sun. That behavior mirrored theoretical designs for advanced light sail technology, a propulsion method that uses radiation pressure from stars. The idea's been proposed by scientists, but never built, and certainly not by nature. Kaku's team believes the surface of the object might even be actively adjusting its reflectivity, what he calls responsive surface geometry. In other words, this thing may be smart enough to steer itself using light. The implication? Oumuamua may not be a rock, it may be a probe, a silent self-directed traveler gliding across the stars without engines, without noise, without being noticed until now. But the mystery deepens. Where did it come from? Using data from the ESA's Gaia mission, which maps billions of stars, scientists traced Oumuamua's origin, and the result stunned them. It came from a region of space known as the local standard of rest. But this wasn't just any spot, it was a cosmic quiet zone with no massive stars, no binary systems, no supernovas, nothing that could have launched an object at interstellar speeds. In short, Oumuamua came from a place where nothing should be flying out. No natural push, no obvious trigger, no reason for anything to leave that zone unless it was sent. And that's what has scientists worried. Could this object have been deliberately launched from an unremarkable region, so its point of origin wouldn't raise suspicion? Was it just passing through, or was it here for a reason? Whatever the answer, one thing is clear. This visitor wasn't just unusual. It was impossible, at least if it's natural. And that might be the most chilling part of all. Typically, interstellar objects are flung into space by powerful cosmic forces. We expect them to come from chaotic regions, where binary stars, supernova blasts, or massive stellar winds provide the kick needed to launch rocks across the galaxy. But that's not where Oumuamua came from. The latest analysis reveals something shocking. No binary star systems within 10 light-years of its origin. No giant stars capable of generating that kind of speed. No recent supernova events. No star clusters with the gravitational power to eject anything into interstellar space. In fact, the place Oumuamua came from is eerily still, a gravitational dead zone, the kind of quiet patch in the galaxy where space rocks should just stay put. So how did it get here? The European Space Agency's data paints a clear picture. Oumuamua appears to have launched from the one region where it absolutely shouldn't have unless it didn't leave on its own. It's as if it was intentionally released from this calm cosmic neighborhood. A stealth launch, hiding in plain sight. No explosions, no drama, just a silent drift toward our solar system. And that's exactly what some scientists are now proposing. If you wanted to send a probe across the stars, without revealing where it came from, you'd pick a place just like this, a zone with no natural ejection forces that could give you away. That's why more and more experts believe Oumuamua may have been deliberately launched. So what do you think? Was this just a weird space rock or something much more intentional? Drop your thoughts in the comments. And if you're following this story, hit subscribe and turn on notifications because it's just getting stranger. And speaking of strange, the most unnerving detail might be what we've recently discovered about how Oumuamua spins. When it was first observed, its dramatic changes in brightness, a tenfold variation every 7.3 hours, were chalked up to chaotic tumbling. That would make sense for an odd-shaped asteroid just rolling through space. But in March 2025, researchers reanalyzed the full dataset using advanced AI algorithms, and what they found changes everything. The latest AI analysis flipped the story. Using deep learning tools built to spot patterns too subtle for the human eye, researchers uncovered something remarkable. Oumuamua wasn't tumbling randomly, it was following a precise mathematical rotation pattern. This changes everything. Let's break down what the data shows. First, it rotates every 7.3 hours with a variance of less than 0.002%. That's an almost perfect rhythm, far too consistent for any natural object wandering through space for millennia. Second, layered over this main spin are tiny adjustments every 43.8 minutes. These micro shifts seem to systematically turn different parts of the object toward the sun. Third, and most revealing, those movements combine to create a scanning motion, as if the object was methodically surveying its surroundings while gliding through our solar system. When aerospace engineers saw this, something clicked. It mirrors designs for smart spacecraft. Rotating like this helps with balancing temperature, maximizing solar energy collection, gathering data, broadcasting signals in multiple directions. In short, this is exactly the kind of rotation you'd build into an intelligent probe, not something you'd expect from a space rock. If that's true, Oumuamua wasn't just drifting through space. It may have been charging up, scanning, or even sending information as it passed Earth. What makes this discovery especially wild is that it took powerful AI to uncover. The object's motion appeared random until researchers fed the full dataset into deep learning models. Then the pattern revealed itself. That alone raises a red flag. Was Oumuamua meant to look natural while secretly following a deliberate program? If so, this isn't space debris. It's technology, built with purpose. And it gets stranger. One of the biggest puzzles is what scientists are now calling the thermal signature paradox. Here's the deal. Everything in space that absorbs sunlight gives off heat. Even the darkest asteroids glow faintly in infrared. So in 2017, when NASA's Spitzer Space Telescope pointed its sensors at Oumuamua just after it had zoomed closer to the Sun than Mercury, scientists expected to see a heat signature. They saw nothing. In 2025, a new analysis confirmed it. Despite soaking up solar radiation, Oumuamua gave off zero infrared energy. That breaks the laws of thermodynamics, unless something very strange is going on. To explain this, scientists are now considering three disturbing possibilities. It's made from a mystery material with thermal insulation properties unlike anything we've seen in nature. It uses metamaterials, engineered surfaces designed to bend and block light and heat. NASA's working on concepts like this for future spacecraft, but nothing near this level of effectiveness. It's using thermal cloaking technology, intentionally designed to hide its heat signature. Each of these options points away from nature and straight toward intelligent design. The third, and most unnerving possibility? Oumuamua may have been equipped with thermal cloaking technology, intentionally built to hide its heat signature. That idea doesn't sound so far-fetched when you realize NASA has been developing stealth systems for future probes. Their work with ultralight aerogels and reflective metamaterials could theoretically reduce the heat an object gives off. But here's the catch. None of our current tech can erase heat signatures entirely. At best, it can dim them. Yet Oumuamua showed no heat signature at all, not even after skimming close to the Sun. This brings us to a chilling possibility. What if Oumuamua was engineered to be invisible, and we only saw it because it flew unusually close to Earth? Which raises an even more pressing question. If we caught one by accident, how many have slipped by without us ever noticing? This thermal paradox is more than just a cosmic curiosity. It seems to break the laws of physics as we know them. And that's exactly why scientists like Michio Kaku and Harvard's Avi Loeb are deeply concerned. A relic from the stars? In early 2025, Kaku published a groundbreaking paper proposing that Oumuamua might not be a functioning craft, but a technological relic. Not a live probe, but the leftover shell of one. The idea is backed by some compelling evidence. Its proportions, 400 meters long, 40 meters wide, don't match any known natural space object. But they do resemble human-made structures like antennas or fragments of solar sails. Its motion wasn't random. AI analysis found that its tumbling had patterns, suggesting a once stable system that's now partially degraded. It emitted nothing, no radio signals, no data streams. Just silent passage, yet far too advanced to be a random rock. This theory ties directly into what's known as the litter hypothesis, a possible answer to the Fermi paradox. It suggests that the first alien tech we encounter may not be messages or ships, but they're space junk, old probes, abandoned tech, cosmic leftovers drifting between the stars. It's not the version of first contact we've imagined, no close encounter, no hello, just debris that hints at civilizations long gone or far away. Or a surveillance device? But Kaku takes it one step further. What if Oumuamua wasn't junk at all? What if it was a sensor, now dormant, but once highly active? Here's the scenario. A distant civilization seeds the galaxy with small, efficient probes. These devices scan planets, gather data, and move on, quiet and undetected. And the data shows Oumuamua moved exactly like one of those. It passed through the solar system's most valuable observation zone, close enough to get detailed readings on Earth and its neighbors, but far enough to avoid drawing attention. Then it accelerated away, as if finishing a mission. If that's true, everything it recorded, our broadcasts, our behaviors, our environment, could already be back with whoever sent it. And we didn't even know we were being watched. The passive probe theory Kaku now believes that Oumuamua may have been a fully functional surveillance device carefully engineered for stealth. 3 key findings support this idea. Its flight path wasn't random. It followed what military analysts might call a recon route, perfect for observing our planets while avoiding engagement. Its physical traits, the heat invisibility, the precise boost in speed and controlled rotation, suggest deliberate engineering, not nature's chaos. It listened during its closest pass to Earth. Data from 2025 shows it stayed in a position ideal for absorbing Earth's radio, TV, and internet signals for about 72 hours. This all fits into a logical surveillance strategy. Active probes that send out signals can be detected or attacked. But a silent observer, that's harder to spot and safer. What would it be looking for? A device like this could scan atmospheres for life or pollution, measure EM emissions to gauge technological development, eavesdrop on our communications and culture survey resources to assess Earth's strategic importance. Kaku warns that history shows a pattern. Reconnaissance often comes before contact, and contact isn't always peaceful. So if this probe captured data about our strengths, our vulnerabilities, and our conflicts, it's already out there. And we're in the dark about who now holds that information. How often are we being watched? The most unsettling revelation isn't about Oumuamua itself, it's the numbers. Statistical models suggest we should expect one Oumuamua-like object to enter our inner solar system every year. That's not theory, it's math based on what our telescopes can and can't detect. Why haven't we seen more? Most are only visible for 5 to 10 days at closest approach. Our sky surveys only cover about 15% of the sky with enough detail. Thermally cloaked objects like Oumuamua are nearly invisible unless they fly right in front of us. So it's not that they're not there, it's that we're not ready to see them. Most interstellar objects slip right past us, hidden in plain sight. Many approach from angles that leave them masked by the sun's glare, making them almost impossible to detect with current technology. That's about to change. Launching full operations in late 2025, the Vera Rubin Observatory is set to revolutionize space tracking. With its 8.4-meter mirror and a powerful 3,200 megapixel camera, it will scan the entire visible sky every 3 nights, giving us a head start, spotting incoming interstellar visitors weeks or even months in advance. And that lead time matters, because for the first time, we might be able to intercept one. A concept called Project Lyra, developed by the Initiative for Interstellar Studies, outlines how we could use Jupiter's gravity and a solar slingshot maneuver, the Oberth effect, to accelerate a spacecraft to 70 kilometers per second, fast enough to chase down objects like Oumuamua. It's a tough mission, but not impossible. With the right tech, nuclear thermal engines or solar electric propulsion, a spacecraft launched within 6 months of detection could catch up within 2 to 3 years, even though it would need 5 to 6 times the power of a Mars mission. But here's the unnerving part. If Oumuamua was truly artificial, then we didn't just miss a rock. We caught a scouting probe, a silent visitor on a recon mission. And history tells us reconnaissance often comes before contact. Statistical models point to something chilling. If these objects are man-made or alien-made, their frequency suggests a methodical survey of our corner of the galaxy, as if someone or something is systematically mapping star systems like ours. Physicists like Michio Kaku have issued warnings. Next time, the object might not just fly by, it might stop, approach, make contact, and if it's powered by technology like what we've observed, we'd be powerless to stop it. What makes this even more profound is that we're not guessing, we're looking at hard science. The evidence from 2025's deep analysis confirms something extraordinary. Oumuamua's acceleration wasn't random. It followed a precise mathematical curve that stabilized its tumbling spin, something no natural object can do. And the motion it followed? A perfect match for light sail technology, but on a level far more advanced than anything we've ever built. It came from the last place you'd expect. According to precise trajectory data from the ESA's Gaia mission, Oumuamua appears to have originated from a part of space that's essentially empty. No binary stars, no massive stellar explosions, no gravitational chaos to fling an object across interstellar space. In other words, a stellar dead zone. That's a big red flag. Why? Because random objects don't just escape from still, quiet regions of space. But if someone or something wanted to launch a probe without drawing attention, that kind of location would be perfect. And the weirdness doesn't stop there. Even though Oumuamua passed within just 0.25 astronomical units of the Sun, closer than Mercury, it gave off no detectable heat signature. When researchers reanalyzed Spitzer Space Telescope data in 2025 using enhanced thermal algorithms, they confirmed Oumuamua absorbed sunlight but didn't emit infrared radiation in return. That's not just odd, it violates the laws of thermodynamics as we know them. This kind of thermal invisibility lines up exactly with theoretical stealth tech, something designed to hide in plain sight. Then there's the spin. Most natural space rocks tumble chaotically. Oumuamua didn't. It rotated with extreme precision, a 7.3-hour cycle maintaining a variance of less than 0.002%. That level of control would be impossible for any object wandering through space for thousands of years, unless it was built to do so. Its bizarre shape, shiny surface, and unexplained boost in speed, all of it points to artificial construction, a possible tech signature that scientists like Michio Kaku and Avi Loeb say we can't afford to ignore. But it's gone now. Oumuamua exited our solar system on a hyperbolic trajectory, never to return. We had only days to observe it, and we were completely unprepared for what we found. And here's the unsettling part. If it was watching us, we'll never know what it saw, or what conclusions it made about humanity, our wars, our tech, our potential, or worse, who it reported back to. Kaku puts it bluntly, Oumuamua might not have been the last. If current models are correct, it may have been the first of many. Quick recap on the known facts. Discovered October 19th, 2017 by the Pan-STARRS telescope in Hawaii, name meaning Oumuamua. A messenger from afar arriving first in Hawaiian dimensions, approximately 400 meters long, approximately 40 meters wide. Shape, long and narrow, either cigar-like or pancake flat, depending on interpretation.